Hello all, I am Saraswati working as Associate Professor, Department of ECE, K.S. Rangaswamy College of Technology. The course name is Digital Communication. Today we are going to discuss about delta modulation. Delta modulation is a simple form of differential pulse code modulation technique. It is 1-bit differential pulse code modulation code to achieve the digital transmission of analog signals. Delta modulation transmits only 1 bit per sample, so that is the present sample value is compared with the previous sample value. So the digital modulation requires a sampling rate much greater than the Nyquist rate. The Nyquist rate may be 4 or 5 times the Nyquist rate. Delta modulation is a technique which provides a strain gauge approximation to an oversampled version of the input baseband signal. The sampling rate higher than the Nyquist rate aims to increase the correlation between adjacent samples of the signal. It simplifies the quantization of the encoded signal. The difference between the input and the approximation is quantized into the two levels plus or minus delta. These two levels correspond to positive and negative differences. The difference between the present sample and the previous approximated sample is quantized into two levels, that is plus or minus delta. If the previous approximation is below the present sample value, then the error is quantized by plus delta. If the approximation is above the present sample value, then the error is quantized by minus delta. So this is a graphical representation of delta modulation process. If the M of t is the original analog signal and the MQ of t is the strain gauge approximation. If M of t is greater than the strain gauge approximation, then the output is a 0. The binary values is a 0. If M of t is less than strain gauge approximation, then the binary output is a 1. So likewise, we can write the mathematical expression. The difference between the present sample and the sampled value of the x of t is called as a error. Is a E of n of ts equal to x of n ts minus x cap of n ts. E of n ts is nothing but error at present sample. X of n ts is a sampled signal of x of t. X cap of n of ts is a lost sample approximation of the strain gauge waveform. Now we can call u of nts as the present sample approximation of strain gauge output. Then the u of n minus 1 into ts equal to x cap of nts. So that is the last sampled approximation of strain gauge waveform. So let the b of nts be defined as b of nts is equal to del of signum of E of nts. It is depend on the sign of error. Error E of nts, the sign of step size del will be the decided. If binary output B of nts equal to plus delta, if x of nts greater than or equal to x cap of nts. If x of nts less than x cap of nts, then binary output is a minus delta. So B of nts equal to plus delta means binary 1 is transmitted. If B of nts equal to minus delta, then binary 0 is transmitted, where ts is a sampling interval. So now we are going to discuss the operation of delta modulation transmitter. The delta modulation uses the oversampling technique to achieve the high signal to noise ratio. In delta modulation system, the transmitter circuit is consists of summer, 1-bit quantizer and a delay unit, accumulator and encoder. So these are interconnected with each other. The summer in the accumulator add the quantized signal, quantizer's output plus or minus delta with the previous sample approximation. So this gives the present sample approximation, that is a u of nts. So we can write u of nts equal to u of nts minus ts plus into plus or minus delta, or u of n minus 1 in Ts plus b of nTs. The plus or minus delta we replace by b of nTs. The previous sample approximation u of n minus 1 into Ts is restored by delaying one sample period Ts. The sampled input signal x of Tns and the strain gauge approximated signal x cap of Nts are subtracted to get the error signal E of Nts. So depending on the sign of E of Nts, 1 bit quantizer produces an output step of plus or minus delta. If the step size is plus delta, then binary 1 is transmitter. If it is a minus del, then the binary 0 is transmitter. Next, the delta modulation receiver. So the delta modulation receiver consists of accumulator and the low pass filter. On the receiver side, it consists of accumulator and low pass filter are used. The strain gauge approximation is reconstructed by passing the positive and negative pulses through an accumulator. The out of band quantizing noise in the high frequency strain gauge waveform is removed by passing the signal through the low pass filter. So the filter has the bandwidth is equal to the original signal bandwidth. So finally we get the original approximated strain gauge approximation signal. The advantages of delta modulation. The delta modulation transmits only one bit for code sample. That's the sampling rate, and the transmission channel bandwidth is quite small for delta modulation. The transmitter and receiver implementation is very much simple. There is no analog to digital converters involved in delta modulation. The disadvantage of delta modulation, there are two types of quantization error occur in delta modulation. One is a slope overload distortion, another one is a granular noise. Let's see one by one. So the noises in delta modulation system. So there is two noises occur in delta modulation. One is slope overload distortion, another one is a granular noise. So from the graph, the slope overload distortion arises because of the large dynamic range of the input signal. So there is the rate of rise of the input signal x of t is so high than the strain gauge signal. Is cannot approximate it. The step size del becomes too small for the strain gauge approximation u of t to follow this steep segment of the input signal x of t. So with result, the u of t falls behind the x of t. So this condition is called as a slope overload distortion. So there is large error between the strain gauge approximated signal and the original input signal x of t. This quantization error is called as slope overload distortion. So the step size of delta modulator remains fixed. Its maximum or minimum, the slopes occur along the straight lines. Therefore, the delta modulator using a fixed step size is also called a linear delta modulator. To reduce the slope overload distortion, the step size should be increased when the slope of signal of x of t is high. So how to avoid the slope overload distortion? To increase the slope samples as fast as the input signal into the maximum slope region, then the following conditions should be maximized. Del of by Ts greater than or equal to maximum of dm of t by dt. So let's see granular noise. So this is a contrast to slope overload. So this granular noise occurs when step size is too large, usually later flat segment of the signal. And this is similar to the quantization noise in pulse modulation system. The granular noise occurs when the step size is too large compared to the small variation in the input signal. So that's for very small variation in the input signal, the strain gauge is changed by large amount because of large step size. So the input signal is almost flat. The strain gauge signal u of t keeps on oscillating by plus or minus delta of the signal. So this error, the error between the input and approximated signal is called the granular noise. To reduce this granular noise, to make the step size small. Thank you.